This doesn't look like this is. Yeah, do you know how to... There you go. Now.
Yeah, I think we decided that was a good level. Yeah.
Ah. That'll do.
What is like for Maria to come back?
Sorry?
What is like for Maria?
Yeah, sure.
So.
I'm in no rush. I suggest sitting on this side because this isn't working. So yeah, better to sit on this side of the room than this side of the room. This is the side of the room where you won't be able to see the presentation very well.
The technician is coming, but I think maybe we should
We'll just start.
Yeah. Is the other one working now?
Yeah, it's working. It's good.
Good morning, everybody. Welcome to the second day of the workshop. Our first talk today is by Adrian Curry, and it's titled Disagreement and Productivity.
Cool, thanks. So over the summer, I've been kind of doing a series of talks where I'm trying to work out this thing that I'm calling productivity. And this is like the fourth of these. And what I've been doing is basically getting this notion I'm playing with and throwing it at whatever the theme of the conference is. And so today I'm going to talk about productivity and disagreement. I think my interest in productivity, which I'll explain what it is in a second, comes out of two things I've been thinking about. The first is kind of emerging technologies in the context of kind of extreme or existential risk. And the other is the way that sciences like paleontology and archaeology work. I'm going to sort of motivate things starting with that latter kind of science. So that is the unprepared fossil room at the Royal Tyrell Museum. If you go to any particular sort of place where paleontologists are, there's probably going to be a big room like this. It's basically a warehouse full of big funny shaped rocks that presumably have fossils in them. These rooms are quite depressing because on each of these big rocks there's a sort of date. And the date is when that rock was extracted. And a lot of these are sort of 1977, 1976. So these things could have amazing finds in them, but we don't know, right? Why does this matter? Well, the idea is when you're a paleontologist, you're continually making decisions about which of these you want to prepare, right? And fossil preparation is a pretty hefty thing to do. So here's Mark Wilson, who's one of the fossil preparators at the Royal Tyrell Museum. He's working on this kind of now quite famous fossil of this nodosaur, this kind of absolutely magnificent kind of mummified dinosaur. This took him 3.5 years, right? So he's a skilled laborer, 3.5 years full-time work, right? So you're making some pretty important decisions when you're a paleontologist or a fossil preparator about which things you want to put all those hours into in terms of preparing. And things can go really wrong as well. So this is the Craptosaurus box, where basically they put things that they start preparing and then realize are no good. Right, so you make sort of bad decisions.
Sorry, Adrian, I think the technician is here, just if you want help, yeah.
Yeah, go for it. I mean, I guess should I just keep going? Yeah, sure. I'll go over here. Okay. So what this has got me thinking about are the sorts of decisions scientists make about what research to pursue. I'm not the only person who sort of noticed this. So in a recent paper, Derek Turner says most of the recent work done by philosophers of historical science, like me and Derek, have focused on the way in which scientists confirm or disconfirm claims about the past. But what about the conclusions that historical scientists draw about the future? Historical scientists and the institutions that fund their work have to make decisions about which questions are worth pursuing and which are best left for another day or bypassed completely. So those of you who kind of know a little bit about the philosophy of science probably guess what I'm going to call this kind of question. This is a question about pursuit. Pursuit is a notion that philosophers of science haven't thought very much about. It's very distracting. It's all good. But what it is kind of pretty easy to get if we just go back to a very old distinction that most philosophers of science now hate, but it's useful here. Discovery and justification, right? So the context of discovery is come up with stuff. The context of justification is support the stuff, right? Pretty straightforward. Well, what I'm talking about is the context of pursuit, which is, given all the stuff you've got, which one do you want to chase up? What thing do you want to investigate? And I think there's a lot of really interesting philosophical issues that come up when we think about pursuit, and I think philosophers of science should be trying much harder to work it out. So I'm going to do a sort of small couple of moves in that direction today. Okay. So first thing I'm going to do is give you this view I've been developing. So I'm going to kind of give an account of the sorts of values which underwrite pursuit. I'm then going to talk about disagreement, and to be honest, when I was sort of told to talk about disagreement, I assumed I would have, lots of things to say, but then I found myself kind of not being as interested in disagreement as I thought I would be. And so I'm going to try and express why I don't find disagreement very interesting, and set this up as a kind of challenge for myself. I'm then going to take you through two case studies, which I think are two different disagreements that have these quite different properties. Both of them are about the evolution of brains, one about a particular brain, and the other about brains more generally speaking. And one, I think, is going to be kind of good in various ways, and one's going to be bad in various ways. And from that, I'm going to kind of develop an account about when disagreement matters for the sorts of questions I'm asking. Okay, so what kind of values underwrite pursuit? And remember, pursuit is a question about where are we at with this?
It needs to be dealt with in a coffee break.
Okay, all good. I'll go back over here then. Okay, what kind of values underwrite pursuit? Remember, pursuit is the following question. You're a scientist. You're trying to work out what research to do, right? I'm going to develop this account drawing on some work that Dan Steele has done in the philosophy of medicine. So he draws a distinction between two different types of epistemic values, and I'm going to sort of develop that to my own purposes. I'm going to call it different names than what Dan does, because I think his names aren't very good. So he distinguishes between what I'm going to call primary epistemic value and secondary epistemic value. So a primary epistemic value is one where, if you exemplify that value, that either constitutes an attainment of a truth or is a necessary condition for a statement to be true. So take, for instance, I don't know, clarity or maybe precision or something like that. I might value that, and if I get it, that seems like that's some kind of epistemic achievement. We can contrast this primary notion with a secondary notion of epistemic value. Here, these promote the attainment of truth without themselves being indicators or requirements of truth. So take having a friendly, gregarious research community. Having a friendly, gregarious research community doesn't constitute an epistemic achievement, but hopefully it promotes them. Right? If I have that sort of community, it's going to do better than one that doesn't have that. Right? So two ways in which I kind of come apart from Steele, in addition to naming, is first, you notice that Dan's putting all this in terms of truth. I like truth. Truth is good. But I think that when we're thinking about scientific epistemology, we need to be much more pluralistic. Right? So instead of truth, I'm just going to use the term epistemic good. And by that I mean, well, whatever you want. Understanding, explanation, good predictions, whatever kind of thing you think scientists are in the business of producing, I'm just going to slot that in there. Another difference is that Steele is thinking about this sort of in a either-or kind of way, right? Whereas I think it's pretty clear that things can have both primary and secondary epistemic values. Okay. And I think this can tell us something about pursuit. So we've got primary epistemic values and secondary epistemic values. If you've got a primary epistemic value that's constitutive, necessary for, or maybe indicative of a particular epistemic good. And so you can say that some scientific practice or investigation promotes those values just when its success is constitutive of, necessary for, or indicates a good which embodies that value. Right? So, fine. Whereas secondary epistemic values, they're going to promote the attainment of those goods, right? But it's not constitutive of it. And so you might say that a practice promotes secondary epistemic value just when it being carried out makes the attainment of a set of epistemic goods likely. So notice that on the primary side, we sort of care about the success of the practice, whereas on the secondary side, it's just you doing it, right? So success is in some sense irrelevant, right? think about this as kind of the byproducts of the scientific investigation. A few other points to make. The way that we're talking about goods here, I think is kind of interesting, where I'm sliding between thinking about goods in a kind of generic way. I might think about understanding, truth, or disagreement, right? The question today is really, should we think of disagreement as a kind of good, something which promotes epistemic values? Or we can think about particular goods, right? So today I'm going to talk about the ancestry of Homo floresiensis. It's an example. So I'm going to be playing fast and loose with that distinction, and I think that's fine. So from this, we can talk about productivity at last. So I think the productivity of a practice is going to be the combination of its primary and secondary epistemic value. And so the idea is, when scientists are making judgments about pursuit in certain contexts, what they're trying to do is kind of maximize productivity, and productivity is the combination of primary and secondary epistemic value. That's the view I've been developing. Just put it in your heads, don't question it. Okay, now let's move on to disagreement. So as I said, I've had trouble kind of getting motivated to think about disagreement. And I want to try and explain why. So typically, when philosophers think about disagreement, as we saw yesterday, it looks kind of a little bit like this. We have these agents, Calvin and Susie, they have beliefs, they make assertions, these things clash, and so they're disagreeing, they're having an argument with each other. It's what you might think of as individual level epistemology, where we're thinking about knowledge as these things that you possess in your brain, right? On my view, this is not a very useful way of thinking about science. I think it's very unuseful if we're thinking about productivity. I'm just going to assert that. Here's another kind of way you might think about epistemology, which I like more, which I think we saw Helen doing yesterday, and I think some of Finner's work expresses this quite nicely, where I have this population of scientists, and I'm trying to work out what I should believe given that population, right? So some of Finner's work says something like, these folk are disagreeing in particular ways, that gives me reasons to trust them, right? I'm more interested in, let's think of it as kind of a tougher version of social epistemology, where I'm just interested in the population. I might care about the beliefs and desires or whatever of the little individuals in the population, but only insofar as this makes the population be productive in particular ways. So that's the kind of perspective that I have. And so disagreement becomes less obviously important. And in fact, I start to worry whether disagreement is really something we should be thinking about for the following reason. Lots of people say, if you've got a scientific community, it's really good for it to be diverse, right? It's really good for you to have different kinds of people who are doing different kinds of work. And I tend to agree with this. Question, what's the difference between diversity and a population in which people disagree? Because if it turns out, by disagreement, I just mean diversity, well, we already have a word for that, right? Why should I care about disagreement when I'm thinking about the productivity of a population? Let's put this as a challenge. Consider a population of Hassock scientists. So, Hassock Chang rather, infamously or famously argues that science should be much, much more diverse than it in fact is. Everyone whips out their phones. And these. So, Hassock doesn't really seem to think that scientists should disagree per se. He rather thinks that you should let 1,000 flowers bloom. So I imagine a population of Hassock scientists, or a population of scientists who are all doing very different things, but they don't really bother disagreeing with each other. There is an active disagreement. They don't spend time trying to, falsify what each other are doing. They don't say, oh, it's cool that you're working with that paradigm, good on you, off you go. I'm happy with mine, here we go, right? There isn't this kind of active disagreement. And so my question is there anything that the population of Hassock scientists is missing versus the population of actually disagreeing scientists, right? So here's a question, how do you convince Adrian to care about disagreement? What's it going to take for disagreement to matter in the context of pursuit? It can't just be diversity, right? Disagreement might have secondary epistemic value as one way of getting diversity, but as you'll notice, I'm actually going to argue against that. So my approach is now to look at two examples of disagreement in science to see what happens. So, case study time, right? The first one's going to take a bit of time, the second one's going to be much quicker. Basically, I'm going to give you an example of a disagreement that I think has been productive and a disagreement that I think has not been productive. So I recently went to what's called the Dead Zoo in Dublin, which is this rather magnificent kind of old school museum. And rather delightfully, I found these three skulls which kind of exactly illustrate the question we're going to ask. So this is Homo floresiensis, this is Homo habilis, and this is Homo heidelbergensis. Is that how you say that? Something like that. The question we're asking is this one more closely related to that one or that one? Right? One thing to note is that the Dead Zoo claims it hasn't changed very much over the time, which surprises me given that Homo floresiensis was found 10 years ago. So actually, I think they're updating stuff. It's outrageous. So, in this cave in Flores, around about a decade ago, 12 years ago, this kind of, I think, absolutely astounding find of these hominids happened. This is Homo floresiensis, or the hobbits. They inhabited Flores from about 95,000 years ago to about 14,000 years ago. Or I think that's been pushed back now. I think actually it wasn't that recent. As you can see, they are small. They also have these kind of primitive characteristics. They're not completely bipedal. They have low encephalization. In other words, their brain size is smaller than you'd expect given their body size. And there's some hints that they have these arboreal adaptations. The thing to really get clear about this, how crazy this find is that these things were alive at the same time as behaviorally modern humans. And they look completely different to any of the kind of later hominids. So it's a really interesting find. We're going to focus on the encephalization. We're interested in their brains. And we're interested in two hypotheses about the ancestry of these guys. Here's one hypothesis. Here's habilis, erectus, floresiensis, humans. One hypothesis is we have a bunch of erectus coming out of Africa. We know that happened. Then they evolve into Homo floresiensis. One weird question about this is erectus are about the same size as us. So how did these things get so small? If you know anything about evolutionary biology, people are going to go, well, they were on an island. And weird things happen when you're on an island. For instance, you get stuff like this. So this is a pygmy chameleon. This is a pygmy marmoset. The chameleon is crazy, right? That's not an insect. That's a vertebrate. It has lungs. It has a heart, right? It's got all the bits we have. And it's tiny, really clever. How come they get small? Well, it's kind of obvious. When you move on to an island, there's not as many resources, and so it's in your interest to be a little bit smaller. Okay? So the thought is, same thing happened to Homo floresiensis. And so geologists, what are they called? Ecologists, fine. Talk about the island rule. So the idea is if you've got closely related lineages, pick a trait, usually body size, is going to be larger on the mainland than on the islands. And the idea is, hey, we're seeing the island rule in action in hominids. Here's the other hypothesis. By this hypothesis, instead of coming out of erectus, we have them coming out of habilis. Right? That looks great, right? We can explain these traits very easily. Habilis was also small, partly arboreal, had low encephalization. Pretty straightforward. But there's a big problem with this hypothesis as well, which is basically this. So here's the world, here's Flores, here's Africa. There's quite a long way between them. And in 2007, at least, there was just no evidence of there being radiation of Homo habilis, right? And so if that hypothesis is true, that radically alters our theories about hominid dispersal, right? Erectus were not the first out of Africa if this hypothesis is true. So we've got the first hypothesis, that the small brain is a signal of habiline ancestry. And this has this upshot that there's this habiline radiation out of Africa. Radical change to how we think the history of hominids goes. Second hypothesis, Homo floresiensis' small brains are a signal of island dwarfism. So everyone has a fight, right? Here's our sort of disagreement. Some people like hypothesis 1, some people like hypothesis 2. We're going to look at hypothesis 2. Turns out we can kind of test this in various ways. So question, could island dwarfism really account for the low encephalization of these little hominid critters? Well, here's a view that some people have about how phyletic dwarfism works over development. Basically, the thought is, the way you develop is you grow for less time. The way you become a dwarf. Makes sense, right? Well, if that's right, which things complete their development earlier are going to be larger than those things that complete their development later, right? And it turns out brain development completes earlier than body development. And so if I'm becoming a dwarf by just cutting off my growing period, my brain will have matured more than my body. And so I should have a larger brain than my body. So we should expect dwarf species to have a higher encephalization quotient than non-dwarf species, all right? So in fact, the island rule should hold the other way for island dwarfs, assuming this is how it develops. So Martin et al., who did this work, they say, hey, look, according to the way they were thinking about this, if this was a dwarf erectus, their brains would be almost twice the size than they in fact are. Right? So that looks really bad for this hypothesis. But people who liked the hypothesis thought, well, this model of how dwarfism expresses itself isn't just going to apply to floresiensis, it's going to apply to a whole bunch of different dwarfs. So what they do is go and look at whether or not this works. If you go and look at, in this case, elephants and hippopotamuses. So you can look at pygmy elephants and pygmy hippopotamuses, compare the encephalization to the adults. Right? When they do this, they found that it just got it wrong. Right? It turns out that the developmental model that Martin et al. Were using just doesn't capture what's going on with the elephants or the hippos, and that's bad news for this model. They say, whatever the explanation for the tiny brain of H. floresiensis relative to body size, the evidence presented here suggests that insular dwarfism could have played a part in its evolution. So notice the move here, where it's like, I'm not saying it did, it's just that it could have. Right? Your objection doesn't work. Now, in 2007, Bromham and Cardillo, again explicitly in light of this hypothesis about Homo floresiensis, tested the island rule in primates. So they grab a bunch of primates and they see whether the ones on the islands are smaller than the ones on the mainland. And they found out it does. That's cool. Stephen Montgomery then looked whether that rule holds relative for brain size. So he grabs Bromham and Cardillo's data, which is about body size, and then turns it into a study on EQ. Right? Interestingly, he says, for encephalization in particular, there is little hint of any consistent effect of insularity, with increases being as common as decreases. The scaling components between brain and body mass vary greatly across pairs from 0.24 to 1.24. So sometimes it's getting bigger, sometimes it's getting smaller. This variability in response is a likely cause of the lack of an island rule for relative brain size. So on Montgomery's view, you're just not getting any real pattern when you get insular dwarfism in primates in terms of brain size. So it's not really giving us a very good signal. But what he can do from this data is give us an acceptable range, right? He builds a little kind of model which says, there's a sort of range of variability that's sort of safe, right? To say that this thing could have been a dwarf given this other thing, right? I'm not explaining that very well. Oh well. So he built a local model of primate brain and body size covariation and uses that to test whether we have the right scaling relationship, right? Whether we get the erectine morphology. And it turns out you don't, right? Things are not looking good for the hypothesis. So Montgomery comes out and says, actually, this hypothesis is not looking very good. And I think there's been a consensus building that suggests that the dwarfism hypothesis is not right. Which is sad, because imagine that you published a paper suggesting that it's probably good. But oh well. Luckily, no one reads philosophers, so no one's going to yell at me about it. So what we've just seen, we've got a point of disagreement, right? Some people think it's erectine, some people think it's haberline. But it's not just that we have a disagreement, we have what I'm going to say points of empirical contention. There are kind of empirical work we can do which is going to directly decide between those hypotheses, right? One question is, do we have evidence of a haberline ghost lineage? How likely would it be for us to have not noticed this? We also have this other one that we focused on about the nature of island dwarfism. We've seen this increasing evidence of this haberline hypothesis. And I think now I'm almost willing to say that they're haberline rather than erectine. Sad, but whatever. But notice that in getting rid of the second hypothesis, we've ended up with a much richer understanding of the nature of the evolution and ontogenetic expression of phyletic dwarfism. We now have these funky models that let us test whether something could be a dwarf of something else, for instance. Which is, pretty cool. In fact, I think that's kind of more interesting than knowing the fate of this one little hominid. So we have these capacities to build these local models which test the island rule for various traits and various lineages. So I want to say this has been a productive disagreement. The active disagreement between the H1 people and the H2 people seems to have produced some primary and secondary epistemic goods, which they wouldn't have otherwise. Hooray. Let's go to the bad case. It's going to be much quicker. One thing which certain types of scientists really like doing is measuring things and then doing regression analyses on them. Here's body size over brain size. A whole bunch of people do this just in terms of brain size. They're interested in what patterns brain size has over evolutionary time. And there are two camps. And so far as I can tell, they kind of hate each other. One camp thinks that brain evolution is concerted. The other camp thinks that brain evolution is mosaic. What does that mean? Well, here's a brain. If you think that brain evolution is mosaic, you think that in principle, I'm able to, for instance, select for larger size for that bit of the brain, right? But not that bit of the brain, or that bit of the brain, right? If I'm a concerted person, I think that actually the brain is developmentally coupled, that I can't make one bit of the brain bigger without making all of the brain bigger, right? So, two models. One, the brain is sort of developmentally modular, so I can tweak things in particular ways. The other, the brain's just this big thing, and if I want to make one bit bigger, I have to make the whole bit bigger. Okay. Seems like these guys should have like a pretty easy time working out their different views, right? You can immediately think ways that you might go about testing this. One way that they go about testing this is by looking at patterns in, usually not the fossil record, but patterns in living critters, right? So they construct phylogenies. Here's a kind of jokey way of expressing that. What you do is you go and look at the patterns of brains over evolutionary time, and you try and see whether different bits of the brain are growing at different paces when you see the whole brain expand at the same time. One thing to note is that the mosaic people expect you to see the whole brain expanding at the same time. They don't expect to see different bits of the brain evolving separately. Why? Well, because they think that the brain is often functionally coupled, right? It turns out that the different functions that the brain has, the sorts of things that are being selected for, are distributed across the brain. So even though in principle I can manipulate them separately, right, actually they almost always end up growing together, right? And so weirdly enough, a pattern that shows whole brain evolution happening at the same time is not an argument against the mosaic folk, or at least so they claim. So that's one kind of bit of evidence. The other is from sort of studies of model organisms. So what they'll do is they'll grab some mices and they'll just artificially select for one particular bit of the brain, right? And try and see if they can get, do mice have neocortex? Whatever. That bit of the brain to get bigger while keeping the other bits of the brain smaller. And, sometimes they can, sometimes they can't. But this doesn't seem to be resolving the dispute, and in fact, it's not doing much for anyone. And I think there's a pretty clear reason. The kind of evidence we're getting is small-scale developmental information. I can know whether or not I can select one bit of this mouse's brain or not. And large-scale evolutionary patterns. But that's not what we need. The thing we really need is information about development over evolutionary time. Because what the people will say, if I have evidence based on what I can do to mice, which I say think holds against the mosaic people. The mosaic people say something like, yes, but development itself evolves, right? And so you could just be working with a critter who has evolved this type of development. The other sort of annoying thing about this debate is that it's what John Beattie would call a relative significance debate. It's not as if the people who believe the brain evolves concerted think it's always concerted. And it's not as if the people who think it evolves via mosaic think that concerted plays no role, right? It's just that one thinks the other's more important than the other, or explains more, or something like this. So there doesn't really seem to be a point of empirical contention in the relevant way. Another thing to note is that the concerted folk tend to be developmental scientists and psychologists, whereas the mosaic folk tend to be evolutionary biologists, right? So they're from different fields. And talking to people in this debate, so far as I can work out, the upshot of this is, half of your papers are summarily rejected because they send it to a mosaic person and you're a concerted person, or vice versa. This looks like a pretty rubbish debate on my view. So what's going on? Well, I think the difference is that the first debate has a point of empirical contention, the second doesn't, right? Remember, we're asking, how do you get Adrian to care about disagreement? I think I've given us a case where we have disagreement which is productive and a case where it's unproductive. What's making the difference? It's this. Disagreements have empirical contention when two things are met. First, there's some empirical fact of the matter whose truth bears directly on the disagreement. That holds in the Floresiensis case, but it doesn't hold for the second case because it's this relative significance debate, right? If you think that one thing's more important than the other, there isn't some empirical fact of the matter that lets you establish that, so far as I can make out. Second, there's got to be some productive method pertaining to that empirical fact of the matter, right? So in the Floresiensis case, we had all this cool stuff we could do to test our models of island dwarfism. In the case for the brain evolution, we don't have the evidence that lets us know about development over evolutionary time, right? And so you're missing some method that gives you those empirical facts. So I think when this holds, disagreement is something we want, right? When we have these points of empirical contention, I think what we get is disagreement driving the development of that productive method. And we have what an AI person might call a cold temperature search. So a hot temperature search, you've got lots of energy, so you can bounce wherever you want on the landscape. Cold temperature search, you don't, so you just sort of focus and go around small. I think what's going on here is this productive method for testing models of island dwarfism has led a bunch of scientists to really focus on a particular question and really explore, really dig that stuff out, which is great. And so it strikes me that active disagreement potentially drives such work. So we can claim that disagreement is productive when it generates this empirical contention. And so to get this, disagreement ought to be leading to the production of these kind of cool epistemic tools, and those tease out these empirical points of contention. All right. How much time do I have?
We have about 20 minutes.
Oh, good. Okay. So let's kind of make some philosophical hay out of this. So if you're comparing some hassock scientists to some actively disagreeing scientists, it seems like one time where I'm going to prefer my actively disagreeing scientists is when I have these points of empirical contention. That's my view. Right? So hey, disagreement does matter. But interestingly, it doesn't matter in the way that most philosophers talk about it. So I'm going to just point at some people. So here's our old friend Feyerabend. Feyerabend, of course, has quite a lot to say about disagreement and pluralism and such. And in some places, he will say that the sort of an ideal for your disagreeing folk is for them to be as different as possible. Right? The idea is there's supposed to be some kind of productive tension that you get when you have people from very different paradigms yelling at each other. And I think that's just not right. Because in those cases, you're not going to have empirical contention. This is not going to be productive, right? On my view, disagreement matters when you have people who actually have a lot in common. That's when we should have disagreement. I think this kind of has upshots for Kyle Stanford's work. So I think Kyle has made it pretty plausible that when we're thinking about kind of big theories in science, we should worry a lot about how conservative science often is, right? We don't really consider alternative hypotheses or alternative big theories as much as we ought to. One thing you might think in light of Kyle's work is, hey, disagreement should be something we're having between these kind of different paradigms. On my view, no, actually you want them to be hassock scientists, right? When I have different paradigms, I shouldn't be letting them fight, right? So the upshot here is the concerted versus the mosaic folk should just be living and let live. They'd be like, fine, you do that, I'll do that, right? Finally, I'm going to end with my bold hypothesis that I've been sort of shopping around at these various talks. I'm not going to explain why there are crocodiles there. It's sort of an artifact of a previous talk. So remember, what I'm interested in is not so much disagreement for its own sake, but this notion of productivity and how it can help us understand the context of pursuit. One thing to notice about that productive debate about Homo floresiensis is that the thing that I thought was really cool about it wasn't the primary epistemic goods. Remember, the primary epistemic goods is what is the ancestry of this critter. The secondary epistemic goods, the byproducts, was, wow, we now understand a lot more about how dwarfism evolves than we did previously, right? That secondary epistemic good looks like it's doing a lot of the work. So on that basis, here's my bold hypothesis. I'm going to say the pursuit worthiness of some practice or investigation is best understood not in terms of its primary epistemic value, but in terms of its secondary epistemic value. That's the thing that I think certainly people like paleontologists are using to make decisions about pursuit. Caveat, where inductive risk is low. I mean, obviously, if you're working on like cures for diseases, that's probably not going to be true, or at least we should be worried if that's true. But I think in lots of other cases, I want to say that pursuit worthiness is the secondary epistemic value. It's the byproducts that matter. And if that's right, I think that has massive upshots for how we go about funding and making decisions about science, because most science is funded on the basis of its primary epistemic upshots. And so if this is right, I think there could be some quite important actual real-world applications of it. And with that ambitious claim, I'll stop.
About 15 minutes of questions, so please raise your hands if you'd like to. Yes?
Thank you very much. Most illuminating. And yeah, I must say my feeling is that I really like the idea that there is a way station between let's say, diversity and disagreement, you know. And I'll really give you a sort of a real-time example. And if you hang around the Dublin Institute for Advanced Studies and listen to the theorists over coffee, or the same in Cambridge, you very rarely hear somebody say, oh, I think that proof is completely wrong. I think that's just nonsense. Nearly always it's, you mentioned the guy talking about relative significance. And there's also a relative fruitfulness, which you very often hear theoreticians say, well, I don't think that's that fruitful a line of inquiry. They don't disagree with it, they just don't think it's fruitful. But I've heard Hasok Chang give a talk more or less on what you were talking about. And one thing that struck me, and you know, this is one of those kind of really awkward, I'm wading into deep water here, but from the scientist's point of view, if you take the concerted model of the brain versus the mosaic, I think a lot of us would say, but that's not two different paradigms. It's two different models, but it's not different. And very often with Hasok, I noticed he sort of fine chops things down into different paradigms that we wouldn't. You know, we would say, no, the outcomes, you know, when you look in from the outside, it looks like two completely different things. But the way in which these models are developed share many of the same assumptions. They simply go in different directions. So, like for me, disagreement between scientists is very, very often not about, oh, that model's completely wrong. As you know, the concerted people read the mosaic papers, and the mosaic papers read the concerted. It's more about which avenue is going to be more fruitful in the long run. And you know, it does come down a lot of the time. In fact, what do we call a paradigm? And I asked him about this after his talk, and he didn't disagree or agree. You know, it seems to be his version is that he would say, for example, as you did, he would say the conservative model of the brain is a different paradigm completely from the mosaic. Whereas I think a lot of the practitioners in the field would see themselves as working within the same paradigm, but one avenue is more fruitful than the others.
Great. So two things. First, I'm pleased you agree with me. You know, like my claim is that it's the fruitfulness that scientists care about. It's not the direct outputs. You know, they have these very particular ideas of what's useful. So yeah, that's the kind of disagreement about fruitfulness is something which I need to start thinking about. And really one way of thinking about this might be scientists making predictions about future success. And that was, I gave that Derek Turner quote towards the beginning. That's kind of the way Derek's thinking about this, and I think that's a very interesting way of thinking about these decisions, especially considering how dangerous a game science is, right? If you make the wrong prediction, your career could be in the toilet, right? As we saw with sort of in Hugh's talk yesterday, the sort of during question time, there was this point that a whole bunch of people wasted a lot of years and lost, you know, a couple of years of your work as a graduate student because you chased the wrong theory. So I think really fruitful. On the paradigm thing, yeah, I think I got a bit of paradigm Tourette's during that talk. I usually try my best to not use that word because it doesn't really mean very much. I agree that, you know, I think the most useful way of thinking about paradigms, the concerted versus the mosaic model are not competing paradigms. To be competing paradigms, it would have to be the case that there's this kind of institutionalization process that you go through when you're becoming a concerted person, which gives you certain ways of solving problems. And there's a bit of that going on, but not much. On my view, the way that you go about carving up science is super context sensitive. I think it's probably right to say that those are models. So yeah, that's really helpful to kind of prod me to be a bit more careful about how I describe that. So thank you.
Thanks a lot. I wanted to ask about empirical contention.
Mm-hmm.
And more specifically, I wonder whether the claim that I thought you were making, correct me if I'm wrong, about empirical contention being a marker of interesting disagreement is perhaps a little bit too strong.
Mm-hmm.
You know, sometimes we think about the sciences as being, you know, the empirical way of investigating the world, because that's, you know, that's kind of a glib way of talking about science. There are parts of science that are highly empirical. There are parts of science that are actually not especially empirical. And it seems to me that empirical contention is extremely important and interesting, right, when it manifests disagreement. But all sorts of less empirically contentious disagreements in the sciences are actually really important and interesting, especially given that you're ultimately interested in fruitfulness or productivity. And we can think of a lot of the debates that happen between scientists or different research programs that are highly theoretical and less empirical as being extraordinarily valuable productivity, sometimes down the line, right? I mean, what we're doing is we're trying to figure out what the space of conceptual possibilities is, but then something that may become empirically testable down the line. We're trying to figure out the way the world could be, right? Based on this. So with fruitfulness and productivity in mind, is it a little bit too strong to say that empirical contention is the marker of interesting disagreement?
Good, I'm going to change my view. Take, for instance, prisoner's dilemma cases, right? So that's clearly been a situation where a whole bunch of really cool work has been done on the basis of this pretty simple model. It's then been applied in economics and applied in evolutionary biology and applied in philosophy, lots of fun simulations, and it really looks like there are sort of things going on there. But I think I can kind of accommodate this pretty easily. I just need to make the points of contention don't necessarily have to be empirical. So you might call them, I don't know, epistemic contention, or I need another word. But the idea is there's some fact of the matter which we have some productive method to get at, right? And so in the prisoner's dilemma case, you have these simulation methods, perhaps, or kind of proof methods and these sorts of things, and that lets you get to the kind of resolvability or something. That lets you kind of have a thing to play at, right? And so that's incredibly useful. You're right that I don't want to say the disagreement is only useful when it's empirical, when it's got this empirical contention. I want to say it's when there's some, let's call it, I have to work out how on earth to actually say this, but I want to say there's some kind of fact of the matter, and there's some method that gets you to that fact of the matter. I'll have to, if you have any suggestions to how I should say that, that would be useful.
Just one other line to throw in. I mean, sometimes it may not be entirely clear what the process or procedure is whereby you might decide. Because some of this work is early work in the development of the field.
Yep.
And so there, it might be interesting, even in the absence of knowing how you might resolve it.
Maybe. So, I mean, I'd have to think about that, because at least the sort of hypothesis I was running with in this talk is something like, in that scenario, you want Hassock scientists. You want people to be like, yeah, cool, you go do that, I'll go do this, we'll meet up in a bit and see if it's worth disagreeing, right? So in that case, I might want to actually just be like a happy pluralist, rather than wanting them to actively disagree.
Yeah, I wonder whether there's much of a difference, because the argumentative scientists might then benefit from fire ovens, tension, right? So you have the happy scientists who contend with one another. They're still happy. Seriously.
Yeah. I mean, by happy scientists, I'm not talking about their like mood. I mean ones that aren't actively disagreeing, which is to say they're not kind of actively trying to take down the other side, as it were. I'd be inclined to think, at least, I'd be interested to see a case that pushes back against this, but I'd be inclined to think actually that wouldn't be productive. But I might be wrong.
All right, well, I've got to rethink my question a little bit, because I have very similar questions as you did, So, yeah, I suppose I was going to ask what exactly you meant by empirical contention, so I suppose I might just take this opportunity to ask you to say a little more if you have any ideas, or maybe you sort of reached your limit of speculation here, about what you mean by a contention. So I was trying to think about the differences between the two cases, and why the one seemed like a better case than the other, and if I remember Helen Johann's paper on Homo properly, they said that there were also kind of like disciplinary or subdisciplinary correlations with the different views there, like you said with the mosaic versus concerted case. And yeah, I'm kind of wondering why I'm wondering if it's really the case that like more productive disputes are the ones where there's some kind of clear method, and does the method have to be pre-existing, or like can it be a surprise secondary epistemic value of debate that we come up with some clear methods to deal with a problem that has seemed kind of intractable or really muddy before, and how can you tell beforehand whether we're going to come up with methods like that? So these are some of the things
Yeah. So that's kind of part of the view in a way. So I need to be careful here about the way I say there is some, right? Because part of the idea is it's the development of the method where a lot of the secondary epistemic goods come from, right? So a nice case of this might be the kind of finding out the color of extinct birds and dinosaurs sort of story, where there's this paper published with like, hey, we figured out that this bird from 20 million years ago is blue because you can look at the color of the cells. It's not that interesting that that bird's blue, but it's super cool that we can now find out that sort of information. And so I think one thing I think you picked out really nicely is I certainly don't mean that the method is kind of pre-existing. The idea is there's some sort of method that we kind of are able to get to relatively easily, right? In the unproductive case, one thing that at least I'm trying to do at the moment with Steve Montgomery and Shahar Avon is try and work out how to make it productive, right? And we're trying to do this by kind of building out some of the theory that's going on, right? And so it might be that there's a sort of normative aspect of this, which says something like, if you do want to disagree, try and make things look like this. That's your aim. But that's really useful, that I need to build in the develop the method bit into that second part.
Hi, I work in commercial paleogeoarch, and I fully support the last three questions. We don't talk about empirical contention, we talk about epistemic contention, and we don't look for method. We start with method, and we model. So paradigms exist within the disciplinary factors, and so we move between paradigms if you're moving from paleogeology to paleoarchaeology, across to paleontology and back again. So we may have some paradigm disagreement through working in a multi-interdisciplinary manner, but within ourselves, no. It's all about modelling, testing models, and epistemic disagreement that fuels productivity. And we are completely reliant on epistemic disagreement, not empirical, because we cannot have an empirical disagreement. It simply can't exist, because we have empirical data, and that's the fact of the matter. It's what we do with it that changes everything. So we won't disagree about the fact that we're looking at tidal mudflats, but we will disagree about where that tidal mudflat is situated in the paleorecord. Does that make sense?
Yep, absolutely. So a really important thing to notice about scientific disagreements, and this came out a little bit actually in some of the talks yesterday, is often disagreements don't really seem to be about what you might think of as direct sort of empirical facts of the matter. Often what's going on is the disagreement is really about some kind of prior kind of views you have about how to best interpret, in this case, how to best interpret the sort of data that you have, and these kinds of things. I think the way this is going to work on the kind of view I'm developing is if your disagreement is actually about how to interpret evidence, then there's a question, is that disagreement a productive one? Which is to say, can you decide between those methods of interpretation? If not, don't bother disagreeing. Just hang out and be productive, right? But if you can, then it might be productive for you guys to actually have an active disagreement, is the kind of view. So I think I can kind of handle these kinds of cases where you have, let's call it second-order disagreements or something like that. I think I can sort of accommodate that. But I definitely appreciate what you're saying about the ways in which particular sciences are interdisciplinary, and they are so in different kinds of ways. One real danger I have when I'm acting at this level of kind of abstraction is that the details matter about how different sciences work, right? I think it's very hard to generalize from what an archaeologist is doing to what a physicist is doing. In fact, I think that would be a very silly thing to do, right? And so one dangerous game that I'm playing is I'm working at a kind of level of abstraction such that it looks like I'm doing these kind of generalizations across science, which is madness, right? The reason why I call that thing at the end a bold hypothesis is I mean that quite literally. It's something which is almost certainly going to be false, but hopefully in a useful way where we can find out the ways in which things are different. So thank you.
Working with geophysics and geoarchaeology, so I am working in physics and I am working in archaeology, and there isn't a disagreement across those two spaces, because the aim is the productivity and the impact is hundreds of thousands of pounds, if not into millions of pounds. So it's no small cost to get your modelling correct. So disagreement has to remain tertiary, not on the surface, otherwise that's seen by the commercial customer and your stuff.
Yeah. So there's definitely one thing that no one's bit me up on yet, which is weird, you should, is that I seem to be abstracting from sociological issues, right? And that's a bit weird. I'm going to think about that some other time. But the other thing you said, good, right? My view says you shouldn't be disagreeing in the case you've described. And so it's good for me if it turns out the scientists are doing what I think they should do. Yeah, so thank you.
Okay. So I was going to invite you to, regarding your thesis at the end, I was going to invite you to...
The bold hypothesis.
Right. So I was wondering whether that fits well with the way sort of scientific funding agencies actually work. So I was thinking, you don't usually like submit a proposal and then have all these secondary epistemic values that you say you realize, but rather you have like an hypothesis that you're trying to test, and then secondary value it might come along, but you don't have like that's not in the proposal. And so I was thinking, in that sense at least, the pursuit of worthiness doesn't seem to be well understood.
Yeah. No, I think that scientists themselves understand pursuit worthiness extremely well. At least when I've hung out with them, they know exactly what they're arguing about, as some of the scientists in the audience have kind of happily pointed out. But I think the people who are funding the science don't seem to realize this. Now, it might be that a really good way of producing pursuit worthiness is to play this weird game that scientists play, where you do your grant application and say, like, I'm going to discover this thing. Yay, that's totally what I'm doing. And then you go off and do the fruitful things that you actually want to do. It might be that's a good way of going, I don't know. But I'd be surprised. So in other work, I kind of argue that, at least in some contexts, in these low inductive risk contexts, the sort of research we should be funding is kind of what you might call exploratory, in the following kind of way. It's not just that there isn't a hypothesis that you're testing. It's also that the hypothesis isn't so precise, right? So one of the things they want is, when you're applying for a grant, is we want to know what the epistemic dividends are going to be, right? And it's very hard to get funded if your thought is, there's some cool stuff that's going to happen. May I just briefly talk a bit longer?
Very brief experience.
Yeah, okay. So a really quick example is, there's this really cool thing that the Tyrell Museum did. There was a big flood in Alberta. They then hired a bunch of postdocs to basically just travel around Alberta finding fossils, right? They had to get the money for that, and they were funded by the government, so they were able to sort of use back doors. But there's just no way you could get funding by most grant schemes by saying, I want to hire some postdocs and put them in the wilderness and see what they find. But that was literally what they did, and they found amazing things in doing so. So I do want to push back quite hard on these kinds of funding models.
We should thank our speaker.
Just a few minutes, I guess, set up there.
It might be.
Just, yeah.
Yes. Yes. Do you think we can do that?
I can try to turn it off here.
If we can.
Do you want to?
Yeah, the laptop, I think.
Do we know if there's a way to turn up?
Yeah, we're just
Okay,
waiting
yeah. Cool.
as soon as it's connected.
Is this working?
I think it takes a bit.
Oh, sorry, I think I need to, because I'm not press the screen, sorry, with the edge room, it keeps on the edge room. I need to switch off edge room first, because otherwise it keeps on appearing, which is annoying. Okay, right. Yeah.
I don't think there's a way to turn off this.
Yeah, exactly. Okay. We could turn it off at the projector. There's a power button on the side.
Hmm?
We could
Turn off the
it off
projector.
actually at the.
Oh, switch on the light. No. Good morning. I'm not going to be as entertaining as Adrian, so I need to rely on full lights. Otherwise, you're going to fall asleep here. So, can you see it okay, or is that too faint, the screen? Is it okay with full lights? Just about right? Okay, cool.
Okay. Our second speaker is Michaela Massimi, and the title of the talk is Points of View, Scientific Evidence and Perspectival Knowledge.
Thank you very much, Thomas. And I want to start by thanking Maria very much for inviting me. And since it's the second day, we are heading towards the end of this workshop. And having organized myself a few conferences, I know that those things don't happen by themselves. So there's a lot of effort and details to look after. So I hope you can excuse me if I want to kind of ask you to join me to thank Maria very much for this wonderful workshop. Right, so my paper today is pretty much work in progress. It's part of a 5-year ERC grant, so delighted to have the EU flag there, on perspectival realism. Just to tell you a little bit what the project is about. It's a project in philosophy of science, so I'm not an epistemologist, I'm really a philosopher of science like Adrian, like other people that have spoken here already yesterday. And the project looks at a particular philosophical position called perspectival realism, which I hope to develop and flesh out as I go along over the next 5 years. And in doing so, I've been paying a lot of attention to interdisciplinary work. So I've been doing field work with particle physicists at CERN, with cosmologists at Dark Energy Survey. I hope to dig better into the literature on epistemology and disagreement. So this is just year 1.5 into the project, so it's a little bit early days for the literature, but I hope to say something to that literature in this topic. And it kind of brings together different strands, really, which are scientific practice, the history of science, it's really also my field, and history of philosophy, so Kant. So this is a crazy paper. Well, I'll be talking about Macfarlane and Kant, if you can think of that combination as possible. There you go. So really my goal today is to introduce a notion of perspectival knowledge that I take it from Kant. I think it can be found in Kant. I think that notion effectively divides into 2 sub-notions of perspectival knowledge, and I'll be saying a little bit about those 2 views on perspectival knowledge in Kant. And in particular, how I think the second notion of perspectival knowledge might be helpful in rethinking some of the debates on disagreement in epistemology. So I will be latching on to some of the discussions that we had at the end of yesterday talk with Maria and Annalisa on Macfarlane, on disagreement and relativism. And I'll latch my discussion about perspectival knowledge to Macfarlane views on disagreement and relativism. But I want to stress from the outset that really my concern is, because I'm a philosopher of science, is again with disagreement in science, in scientific matters. So the structure of my paper is the following. I want to start with a couple of examples of what I'm going to be calling, following Macfarlane, interconversational disagreement, when 2 communities of scientists disagree on a given subject matter. So one example is kind of imaginary, but not too far from reality. It's taken from chemistry. And the second example is taken from contemporary debates in cosmology, and something that I've been looking at very closely on galaxy rotation curves and 2 different programs on dark matter. In section 2, I introduce those 2 notions of perspectival knowledge, and as I see them at work in Kant. And in section 3, I bring those notions of perspectival knowledge to bear on discussions about interconversational disagreement and Macfarlane. So that's the plan. And let's get started with 2 examples of interconversational disagreement in science. So I said the first example is an imaging example, but not too far from reality, as we're going to discover very soon. It's discussed by Joseph Laporte in his book Natural Kinds and Conceptual Change. And so here is the scenario. We can imagine these 2 communities. Scientific community A that believes that deuterium oxide is not a kind of water. Let's call it water, and in the language of a twin Earth in the year 1905. And there is a scientific community B that believes that deuterium oxide is a kind of water. It's an isotopic variety of water. So let's call it heavy water, as the Earth scientists called it in 1935 when deuterium oxide was identified. Now, Laporte discusses this example in chapter 4 of his book, and it's really meant to be a counterexample to Putnam causal theory of reference. So he uses it as an argument against the Putnamian view that we discover the essence of water to be H2O, and that the reference of natural kind terms like water is given by bearing same macrostructural kind relation to paradigmatic samples of water on planet Earth. So here's the imaging scenario that Laporte presents. He says, well, imagine it's the year 1905. We have an expedition of Earthlings that reach a planet, let's call it some sort of twin Earth scenario a la Putnam, and they bring with them samples of biological and chemical substances from planet Earth. They reach this new planet, and they look at the stuff that fills oceans and lakes, and the stuff looks very much similar to our water. But they soon find out some important differences. They find out that it's poisonous to all forms of life, so no fish, no plants can grow in the oceans in the planet. They found out that the boiling point is different. They do some chemical analysis. They found out that there is something strange in the chemical composition of the hydrogen, where in addition to the proton, there's a neutron. So not knowing what the stuff is, in honor of this planet, which is called the deuterium Earth, they call it the deuterium. And they decide to call the stuff that fills oceans and lakes water, with a D, to make it the difference with the water of planet Earth. They also discovered that a powerful bomb has been built with that element, and so forth. So 30 years go by, it's the year 1935, and the Earthlings go back to planet Earth. They bring samples from deuterium Earth, and one of that samples is water. They bring it to the Earth scientists and say, here's a new element that we just found on deuterium Earth. We call it water. And the Earth scientists say, no, it's not a new element. It's just an isotopic variety of water that we have also in the meantime discovered, and we call it deuterium oxide. Now, Laporte says, okay, what do I think this story shows? This is the moral of the story that he draws. He says, well, I think it shows that we didn't discover that deuterium oxide is water, and hence we didn't discover that water is identical to H2O. We cannot say that our space travelers were just flat wrong in concluding that D2O is not what they've been calling water, and that we are just plain right in concluding that it is. In other words, according to Laporte, what we have discovered is that it's a matter of semantic stipulation, what we call water. Things could have gone otherwise. We could have decided to go down the path of the Earthlings in not identifying deuterium oxide as a kind of water, but as an entirely different chemical species. Now, I mentioned at the beginning, this is not too far from reality, because as a matter of history, when the American scientist Harold Urey discovered deuterium in the lab, despite the announcement in the Times of the 9th December 1933 about nature's long heat secret, a new kind of water, no war. A debate began at the Royal Society in London about the nature of this new chemical element, and so these are some of the characters that took part in the debate, and you can read all about it in the proceedings of the Royal Societies, which are available online. It's a fascinating debate. So here we have on the left-hand side Soddy, and he was the father of isotopy, so the person that introduced really the concept of isotopy in chemistry. And he was the one that thought that deuterium oxide was not a kind of water, was not an isotope. The isotope should not be considered as chemically separate elements. So because deuterium oxide is chemically very different from protium oxide, what we normally call water, in the sense that their boiling points are different, they have very different properties. It's poisonous to, deuterium oxide is poisonous to forms of life, you can build an H-bomb with it and so forth. Soddy was of the view that isotope should be elements which were not chemically separable, and therefore he believed that deuterium oxide should not be regarded as a kind of water. Rutherford held the opposite view, so he thought that isotope could include varieties which are chemically very different from each other. They have macroscopically very different properties, even if at the macroscopic level the difference is just in the atomic weight. And he proposed the name diplogen for the new substance. And this is Niels Bohr, who was a staunch defender of the view that really classification of chemical elements should be done on the basis of atomic number and not atomic weight, and therefore he just called it hydrogen. It's like it doesn't matter, whether there is a proton or a neutron in the nucleus. What matters is the electrons and the atomic number, and that's all. So this is an interesting first example of what I'm going to be calling interconversational disagreement. It took about a year before the scientific community decided to adopt the term deuterium that Harold Urey himself adopted and decided to consider isotopic varieties that are chemically different as different varieties of one and the same chemical elements. Let me give another example of interconversational disagreement. This is taken from cosmology. As I said, something I've been looking at more recently. So in current cosmology, there is a debate about what is called the concordance model or lambda CDM model, which is the official standard orthodox model used by cosmologists to describe the universe. According to this model, 73% of the stuff in our universe consists of dark energy, 23% consists of dark matter, and only a very small portion consists of baryonic matter, which is the stuff that basically all atoms and molecules are made of. And obviously there's a big debate about, okay, what's the nature of dark energy and dark matter, and lots of research on finding evidence for dark energy and dark matter. I'm going to be talking about dark matter today, not really dark energy, because what is interesting about dark matter is some specific challenges that scientists face in modeling dark matter at different scales. So the best evidence that we have for dark matter at the moment comes really from large-scale structure. So for stuff like this beautiful WMAP, the person behind the experiment that led to maps of this kind that just got the Institute of Physics award this year. Those are beautiful maps of the universe where the overdense blue regions are regions where you can zoom in and you can find there the seeds and fluctuations in the cosmic microwave background that eventually led to the productions of what are called the large-scale structure. Those beautiful filaments are obtained by computer simulation and they show the formation of galaxies over a long period of time. So cosmologists use data from cosmic microwave backgrounds and computer simulation to infer that there must be dark matter as this invisible new kind of entity that can explain the sort of nucleation sites for the formation of this large-scale structure in maps like these ones. The other piece of evidence for dark matter comes from galaxy clusters. So this is the Abel 1689 galaxy clusters. You have thousands and thousands of galaxies that seems to cluster around the center. You can see this is via weak lensing. There seems to be kind of clustering around the center of this big lump of different galaxies. Now, using gravitational force alone, you won't be able to explain this phenomenon. So back in the 1930s, a Swiss scientist called Zwicky introduced the idea that there must have been some, he used the one they call it dark invisible matter that could explain this phenomenon. And the idea of dark matter really didn't come up again until the 1960s when people started dealing with problems about the stability of spiral galaxies and so forth, and now it's part of our cosmological model. So anyway, this is one of the best evidence for dark matter. But what is dark matter? Right, I mean, that's where there are a lot of experiments currently going on. So the best hypothesis that we have at the moment is that it's a WIMP. A WIMP is a weakly interactive massive particle. It's a particle that doesn't interact very easily with other particles. A possible candidate could be SUSY neutralinos. So for people that work in particle physics, there is this area called supersymmetry. People have been looking for about 2 decades, if not more. Without entering into the details of SUSY, one of the objects of the SUSY are neutralinos. So those are possible candidates. But people at LHC, at CERN, have been looking for neutralinos. No evidence has been found as of today. There are more direct detection experiments for dark matter, people that go in the mines in South Dakota and try to detect WIMPs, no matter whether they are neutralinos or not. Again, no evidence has been found. It could be an axion, which is another hypothetical particle that has been introduced to explain CP violations. So lots of different hypotheses, no evidence yet for dark matter. And coming to the mesoscale, so not the micro, not the large, but the mesoscale, well, this is where things become interesting. This is where the disagreement somehow begins. Very few physicists would dispute evidence for dark matter at large-scale structure, okay? And big experimental efforts are being done at the macro scale. But the mesoscale, there's been a bit of a controversy. And the controversy has to do with phenomena like this. So this is the galaxy rotation curves. So take any spiral galaxy and plot the velocity of the galaxy over the radius. What you would expect on the basis of classical physics is that the velocity should decline in the outskirts of the galaxy. So the farther out you go from the center, the less mass there is, the velocity should decrease. What you actually observe, and what was observed by Vera Rubin already at the end of the 1970s onwards, is that actually the velocity tends to stay flat. That suggested that there must be some halo of stuff, invisible, dark matter, that can explain why this velocity doesn't decrease. Now, that's one explanation. The other explanation, and this is the rival research program, this is where the controversy and the disagreement begins, was proposed by an Israeli physicist, Milgrom, in 1983. And according to Milgrom, there is no need to introduce dark matter halo to explain a phenomenon like this. All we need is to modify Newton's second law, Newton acceleration laws at the galaxy scales. So the idea is that there is a scale, a parameter called a north, and whenever the velocity of the galaxy is below that parameter, then we start observing this massive discrepancy between what's expected and what's observed. Now, this is the scenario that we have of disagreement, interconversational disagreement at the mesoscale in contemporary cosmology. So we have the lambda CDM model, which is the official model that is currently retrieving galaxy rotation curves in terms of dark matter and in terms of additional baryonic physics, which is required in computer simulation to reproduce some specific problems that lambda CDM faces at that level. So I won't bore you with technical details, but there is something called the baryonic Tully-Fisher relation that's been the object and the bone of contention in this controversy. There's a specific way in which the baryonic mass is related with the velocities of the galaxies. And that piece of evidence is usually regarded as evidence for MOND rather than evidence for lambda CDM, or anyways regarded as a problem for lambda CDM. So people within the lambda CDM model, which is the accepted view, deal with the problem by looking very, very carefully at computer simulation and how they can plug into their computer simulation stuff about active galactic nuclei, supernova explosions, all sorts of interesting baryonic physics that has to do with galaxy formation and star formation to try to retrieve baryonic Tully-Fisher. This is an ongoing debate. There was just an article that came out, I think, a week ago of someone that said, oh, we found a new computer simulation within lambda CDM is able to produce exactly baryonic Tully-Fisher. That's it. We got it right. People in MOND explain the same fact at the level of galaxy rotation curves by modifying acceleration law, but not introducing dark matter. They have big problems in explaining large-scale structures, okay? So MOND is a phenomenology, is regarded as a phenomenology, and is not really able to explain the big map that I showed you at the beginning about cosmic microwave background. So they are facing much more problem than lambda CDM. Someone at the dinner I had, it was a cosmology conference just a couple of weeks ago, told me very quietly during dinner, actually, let's go back to Hugh's point yesterday. It's like if you go around saying that you support MOND, you won't get a job this day in a physics department. You know, as bad as that, the situation. So there are still people that believe in MOND, and people that are doing research in that field, but the upper end seems to be definitely on the lambda CDM side. And then there are the, well, I don't know how to describe them, whether mavericks or not. There are loads of people that have been trying to come up with a middle ground in between those two. So there's a Verlinde proposal very recently on emergent gravity. Justin Curry and his team at Pittsburgh that has been working on dark matter, superfluidity, people that try to reach a compromise between this. Okay. Now, why am I telling you all this long story, and what does that matter for disagreement? Okay, this matters because, coming to the topic of today's workshop, I want to see whether we can make some progress on the issue of interconversational disagreement when you have not just one scientist disagreeing with another, but different research communities, like people working in lambda CDM versus MOND, or people like in the imaging scenario of deuterium earth, different scientists disagreeing about whether deuterium oxide is or isn't a kind of water. I want to go back to McFarland that we discussed yesterday with Maria and Annalisa, because McFarland discusses interconversational disagreement within the context of his broader discussion on contextualism and relativism. Now, as it was already made very clear yesterday, his concern is really with matters of taste, whether something is delicious, like rhubarb crumble, whether a joke is funny, and so forth. So it doesn't really discuss scientific matter, but because I'm a philosopher of science, I'm interested in scientific controversies, I'm trying to see whether those ideas that Macfarlane put forward have some sort of legs to go also and to play out in the debate in science, in the controversy in science. So that's his view. He says, okay, you can take two positions in, when it comes to disagreement. You can be a contextualist or you can be a relativist. The contextualists usually have the following strategy of resorting to what Kit DeRose, following David Lewis, calls a single scoreboard strategy. So it's Macfarlane 2007. He says, well, instead of taking partially subjective discourse to be partially and covertly about the speaker, we take it to be partially and covertly about some aspects of the shared conversational score. So the score might include a shared epistemic standard that changes as the conversation evolves, getting more stringent when the stakes are high, less stringent where the stakes are low. Now, Macfarlane concedes that the contextualist response usually fares well in terms of capturing the subjectivity that goes on in disagreement, but it doesn't give us enough disagreement, so he complains that the contextualist single scoreboard strategy works only in situations where we share a scoreboard, so in situation of what he called intra-conversational disagreement, but not in situation of inter-conversational disagreement, when we have two different people that don't even share a common platform, don't even share a common scoreboard. Those are the situations where Macfarlane claims the relativists do better, and we should go relativist, because he claims for the relativist, what we can do is to go down the route of making the truth of those knowledge claims as somehow dependent on the perspectival context of assessment. So this is what he introduces. He makes this sort of kind of perspectival move. He says, okay, this is my relativist account of how two parties may disagree as assessed from a perspectival context C. Two parties disagree when they can both be accurate relative to this context of assessment C, in the sense that there is a proposition that one party accepts and the other party rejects, and B, the acceptance and rejection cannot both be accurate as assessed from this context of assessment. And that's how he defines perspectival accuracy. He says, well, an acceptance or rejection of a proposition P at a context CU is accurate as assessed from a context CA, so there's a difference between a context of use and context of assessment, if and only if P is true or false are the circumstances WCU SCA, where WCU is the context of use, is the world where P is uttered and is asserted, and SCA is the standard, in this case the standard of taste, because I said he's discussing really matters of taste, of an assessor in a context of assessment. Now, the net outcome of this strategy is that two parties may genuinely disagree because accepting proposition P in world CU and rejecting proposition P in the same world CU cannot both be accurate as assessed from a context of assessment and the standards and the norms of an assessor that is separate from the two users, okay, and they can therefore assess that they can both be accurate. So there is a perspectival move in saying disagreement has to be relativized to a context of assessment as a point of view or a perspective from which we can see that they can both be accurate, although it's perfectly fine to accept and reject the same proposition in the same world, because we can make an assessment from the point of view of an assessor and its perspectival standards of taste or epistemic norm or whatever it is that we are assessing. Now, can this notion of perspectival accuracy be extended to science? Can it be extended? Can this proposal be made to work in case of scientific disagreement, like the ones I was describing before? Can, for example, can we say that Soddy and Rutherford disagreed on whether or not deuterium was an isotope of hydrogen, because Soddy rejected while Rutherford accepted the proposition that it was an isotope of hydrogen? vis-à-vis the standards of an assessor in some perspectival context of assessment? Or can we say that Mond supporter and Lambda CDM supporter disagree because the former reject and the latter accept the proposition that dark matter causes galaxy rotation curves vis-à-vis the standards of an assessor in a perspectival context of assessment? So the immediate worry that I have is, okay, who's the assessor in each case? Okay, give me an example of a perspectival context of assessment in the case of science. While it may be perfectly reasonable in matters of taste to say that, I don't know, Maria is our assessor, and I say rhubarb crumble is delicious, and Adrian says rhubarb crumble is horrible. So vis-à-vis Maria's standards of taste, she is in a position of deciding that while we can genuinely disagree, we cannot both be accurate vis-à-vis standards of taste about what's right or wrong with the rhubarb crumble. The case doesn't extend easily, seems to me, to scientific matters, because we don't have such an assessor at end. Who's such an assessor? It can obviously be one of the people involved in the disagreement, because the context of assessment cannot be one and the same as the context of use. I think the whole purpose of this perspectival move was precisely to make relativism not get lost, and making sure that speakers don't talk past each other. They can genuinely disagree with one another, but there is a way of assessing that they can't both be accurate vis-à-vis someone else's standards of taste. But the case is very difficult in the case of science, because there is no unlimited oracular perfect physicist, to echo Ned All, that can act as such an assessor to resolve matters of dispute in science. So in what follow, I want to suggest that maybe the contextualist was right, after all. So I want to kind of defend the single scoreboard strategy of David Lewis and Keith DeRose against McFarlane. But I'm going to give it a twist to that story, because obviously the challenge is, okay, where is the single scoreboard? Where is the contextually single scoreboard when it comes to Mond and Lambda CDM, or when it comes to the deuterium oxide story? Okay, what played their role in science? And I'm going to give you the spoiler. My line is that metaphysics plays such a role as a metaphysical scoreboard. That's the role of metaphysics in science. That's the role of metaphysical ideas. But before we get to that point, I'm going to go through a roundabout route and tell you a little bit about Kant's notion of perspectival knowledge, and why I think Kant had a point when he talks about ideas of natural kinds as what David Lewis would call a single scoreboard for solving interconversational disagreement. So in what follow, I'm going to really articulate two notions of perspectival knowledge that I see at play in Kant's view, and I'm going to, one of them is more familiar probably to everyone in this room. The other one probably is less familiar, and it's the one that I want to cash out, because it's the one that's going to be important for defending the single scoreboard strategy within a broadly contextualist approach in matters of scientific disagreement. So that's the plan. Now, back to Kant. You'll bear with me, there has to be some Kant here. Now, Kant put forward two notions of perspectival knowledge. The first, and by far better known and discussed, is what I'm going to be calling knowledge from a vantage point. I'm going to be calling it perspectival knowledge 1. And this is really the knowledge afforded by our cognitive faculties. So for Kant, primarily the faculty of sensibility and the faculty of understanding. On this first notion, Kant perspectival knowledge is a reaction against what might be called absolute knowledge, or if you like, the Hegelian knowledge from nowhere. Knowledge whose main task is to produce accurate representation of a ready-made world. But there is a second notion of perspectival knowledge, which is surprisingly less well known, has attracted a lot less attention even within the very crowded Kant scholarship. And I'm going to be calling perspectival knowledge 2, and it's knowledge towards a vantage point. Kant see the second notion of perspectival knowledge as delivered primarily by the faculty of reason. So you have these three different faculties: faculty of sensibility, faculty of understanding, faculty of reason. You also have the fourth faculty, is faculty of reflective judgment. So in fact, later on in his life, he kind of reassigned the faculty of reason to the faculty of reflective judgment. And it's really to this notion that I want to concentrate my attention on, because I think there are some really interesting insight in what Kant has to say on this issue that bears on discussion about disagreement and the single scoreboard strategy of the contextualist. Now, Kant's theory of knowledge has really often been understood and read primarily along the lines of perspectival knowledge 1. So a classic example is this book by Adrian Moore called Points of View, where Adrian Moore has interpreted Kant's synthetic a priori knowledge as what I call perspectival knowledge 1, as knowledge through, quote, native spectacles through which we view the world. So it says it's knowledge pertaining to the spectacles, these faculties, the faculty of sensibility and understanding that in a way we're all born hardwired with. So it's knowledge pertaining to our own epistemic faculty, and we cannot take the spectacles off. So we view the world, we come to know the world via those epistemic faculties, the faculty of sensibility and understanding, like spectacles that we cannot really take off. So our knowledge is always from a specific vantage point, the vantage point of our own epistemic faculties. In particular, is perspectival 1 in the sense that we constitute for Kant's object of experience as the product of applying categories to the spatio-temporal manifold. But obviously, if that's the case, one worry arises for Kant, and the worry is how are we going to make sure that we share knowledge, that we have knowledge we all agree on? How do I know that my object of experience, my experiencing, I don't know, this laptop being on top of this desk right now, coincide and it's something that we can all agree and share with everyone else in this room? How do I know that each and every one of you come to constitute, in the Kantian sense, this object of experience exactly in the same way as I do, right? Even if we share exactly the same faculty of sensibility and faculty of understanding, how do we know that we have knowledge that is communicable, that is universal, that is something that we can share? So that's a worry that Adrian Moore raises in this book. So he says, well, Kant, with this idea of perspectival knowledge, is really on a slippery slope. So on a slippery slope to what he called transcendental solipsism. How do we know that, my knowledge of the objects of experience of the phenomena is not something that somehow stays in my brain as a product of my faculty of sensibility and understanding, but it's not something that I can share, I can communicate, I can talk about with other people. Now, I want to draw attention, and really somehow as a response to Adrian Moore, to different notions of perspectival knowledge. I think Kant had the tools and resources to deal with this problem of transcendental solipsism. I don't think Kant ever ran into the problem. And that's why he had the third faculty in place. He had the faculty of reason, and was there for a reason, because the faculty of reason has precisely that role, the role of providing a common platform, a common scoreboard that allows us to understand each other, communicate, and share the common collective knowledge. That's exactly what the faculty of reason does in Kant. So there is this beautiful metaphor that introduces of ideas of reasons as foci immaginari in Latin, as imaginary vanishing standpoint. And this is the key passage, sorry, it's a bit long, in the Transcendental Dialectic, in the appendix to Transcendental Dialectic. How am I doing with time? Can I read it, or shall I just skip it?
You have 15 minutes left.
15 minutes left, okay. Okay, I'll try to be quick. This is what Kant says in this passage. He says, okay, transcendental ideas. And when he talks about transcendental ideas, he means lots of things. But for example, in the example he gives just after this passage, he talks about pure water, pure earth, pure air. So ideas of natural kinds, effectively. Although, mind you, I also believe that God and soul and world are transcendental ideas, but that's another story. Transcendental ideas have an excellent and indispensably necessary regulative use, namely that of directing the understanding to a certain goal, respecting which the lines of direction of all its rules converge at one point, which, although it's only an idea, it's a focus imaginarius, it's an imaginary vanishing point. It's a point from which the concept of the understanding don't really proceed, since it lies entirely outside the bounds of possible experience, nonetheless still serves to obtain for this concept the greatest unity alongside the greatest extension. So it goes on to refer to these imaginary points as illusory. They're not real things, they're not placeholder for real metaphysical objects. They're illusory, but they're indispensably necessary for a correct use even of our faculty of understanding. Without those imaginary points, we can't even have a correct use of our own faculty of sensibility and understanding. It plays such an important role in Kant. And this is what I meant by perspectival knowledge too, really. I want to suggest the following: the ideas of reasons offer the understanding rules for seeking out unity and order among the cognition delivered by the faculty of understanding, and not by positing real metaphysical objects, but by laying down the rules that the understanding must follow if we want to go beyond any given experience. So ideas of reason, and as I said, that the example he gives are pure water, pure air, and what was the other one? I can't remember. Pure earth. Act by offering an imaginary standpoint. Think of it again in the analogy with optics, like a vanishing point from which lines are shot out. And these lines constrain and structure the abstract space of reason within which the understanding cognitions are ultimately located. So I want to suggest really reading Kant in analogy with what perspectival drawing has achieved in the history of art, because that's exactly the analogy that Kant is using of the vanishing point taken from optics. So if we go back in the history of art, perspectival drawing made this revolution in the Renaissance art of using a vanishing point as a focal point towards which all lines converge, back to Albrecht Dürer, one of the very first treatises on the history of perspectival drawing. And the net outcome of that, in the words of the art historian Panofsky, for example, is that we transform the medium, the panel, the wall, into a window from which we can look at a slice of reality. And that's the outcome. And the outcome is that we move from something like the mosaics of Montreal, where the pictures are crowded on the borders of the panel, to a spacious and ordered display of figure in the Renaissance art, like in Piero della Francesca, for example. So, in analogy with exactly the role of perspectival drawing in art, and taking really the cue from this Kantian idea of perspectival knowledge, I suggest that we read perspectival knowledge too as follows. It's knowledge towards a common shared vantage point, the vantage point of reason's idea, where reasons offer imaginary standpoints that can act as a shared conversational scoreboard with respect to which individual knowledge claim can be assessed. So let me go back then to my two examples with which I started this paper, the example of deuterium oxide and the dark matter. So in both cases, there are two epistemic communities. They are genuinely disagreeing on the evidence equally available to both of them about properties of this liquid, deuterium oxide, or about evidence on galaxy rotation curves. How to account for this kind of interconversational agreement in science? Well, my idea is that maybe the contextualist has a point, that we need to resort to a single scoreboard strategy. And a single scoreboard strategy, in the case of science, is not given by an ideal assessor, is not given by some, ideal context of assessment or, shared scoreboard of some kind. It's given by metaphysics. It's given by metaphysical ideas, ideas of natural kinds. So in situations of interconversational disagreement, as when the proposition deuterium oxide is not a kind of water, the truth or falsity of that claim for the different communities is ultimately a matter of using an idea, the idea of water, for example, the natural kind of water, as an idea that includes isotopic variety, as the single scoreboard that allows to resolve interconversational disagreement. So, So I propose the following. I propose some sort of perspectival interconversational disagreement where a proposition P is accepted or rejected as true or false by an epistemic community, let's call it EC1 or EC2, if and only if the proposition is true or false at WEC1 and I rule CA, or WEC2, I rule CA, where W is the world of the epistemic community C1 and vice versa for epistemic community 2, and I rule CA is the idea that acts as a rule in an ideal context of assessment, so an imaginary standpoint playing the role of a shared conversational scoreboard. So going back to the example of deuterium oxide, one might argue that the interconversational disagreement between the earthling and the earth scientist as to whether deuterium oxide is or isn't a kind of water depends very much both on facts about the worlds, facts about twin earth and earth, where these judgments are made. So twin earth is filled with deuterium oxide in a way that planet earth isn't, but also depends on the ideas of reason in an ideal context of assessment, and it is ultimately the commitment to the idea of a natural kind water, which includes isotopic variety, that underpins the earth scientist acceptance of deuterium oxide as a kind of water, what they call heavy water, as much as it explains the earthling rejection of deuterium oxide as a kind of water. So one might say that the earthling in Joseph Laporte's Imaging Story had not embraced the idea of isotopes as chemically separable substances, pretty much as Soddy, the father of isotopy, had not embraced such an idea in the debate with Rutherford at the Royal Society. So interconversational disagreement can still be retained and be made perspectival, but instead of invoking some oracular perfect physicist to define the context of assessment, we can have what Kant called ideas of reasons, metaphysical ideas, such as ideas of natural kinds, acting as rules or imaginary standpoint from which diverging knowledge claims can be assessed and evaluated. Similarly, the idea of dark matter might act as a rule in an ideal context of assessment to explain the interconversational disagreement between lambda CDM and Mond proponents. And what's at stake in most of the debate is not so much the idea itself of dark matter, but how we see, for example, the observational evidence about galaxy flat rotation curve being explained by that idea, what kind of mechanism, what kind of baryonic physics we need to introduce in computer simulations, and so forth. So to conclude, it is really the standpoint of human reason and its ideas, a standpoint that we all equally share in the endeavor that we call science, that allows us to explain the perspectival nature of interconversational disagreement in scientific matters. And whatever one may think today of Kant's doctrine of the transcendental illusion, I hope I have briefly shown the relevance of some of those Kantian ideas for contemporary debates about scientific disagreement. Despite any threat of solipsism that people like Adrian Moore have seen in Kant, and despite the risk that people have seen of speakers talking past each other, perspectival knowledge too provides in fact the best safeguard for shared and collective knowledge, exactly for the kind of knowledge that we have in science. I just want to conclude by saying that as much as really Kant is remembered for his demise on metaphysics, in my view his account of perspectival knowledge is really a powerful reminder of the importance of metaphysical ideas for scientific knowledge if we understand them properly as playing a regulative role as vanishing points, not as placeholder for real metaphysical objects. Thank you.
I'm still struggling with the metaphor of perspectival knowledge. And I would think that we can express both Macfarlane's insight, if it is one, and Kant's insight without that metaphor. Case of Macfarlane, as soon as the perspectival accuracy of a proposition is made dependent on the statements being true relative to some standard of taste, I think nothing bars from making this standard of taste part of the expressed proposition, to the effect that both speakers do not express the same proposition. Of course, Macfarlane doesn't want to have it that way, but I think the challenge for him is to explain exactly what feature of the context, for example, standard of taste, cannot be expressed without the metaphor of perspective. Now Kant, on the indispensable role of transcendental ideas, I think what's indispensable is not the metaphor of perspective, because instead of forming a notion of how the world would look like from a point that lies entirely outside possible experience, we might as well speculate which truths an omniscient being would know. And then in the second step, we skip the notion of an omniscient being and retain the notion of objective truth. And I would submit that what's really indispensable is the notion of objective truth, but not the explication of it in terms of a God's eye perspective outside the bounds of human experience.
Right, thank you. Good point. So the first point about Macfarlane, If understood correctly, your worry, the worry is, can't we have the standards of assessment as part of the kind of context of use when we need this perspectival move, if understood it correctly? Now, I'm not McFarlane expert here, there are other people that know this stuff better than me, but as I understand it, he really wants to make sure that disagreement is not trivialized in the sense of having two parties that one accept, the other reject a proposition, but they don't talk past each other because there is no way.
He doesn't want to have it though, because
yes.
If we have two propositions,
they cannot both be right.
The disagreement would vanish as,
that's right.
as
they would just talk past each other.
relativism predicts it does.
That's right. So he has a reason for introducing this idea that there has to be obviously a distinction between context of use and context of assessment, and that was my starting point. The point is okay. I agree with this move that in order to capture and non-trivialize genuine disagreement, we need the notion of perspectival accuracy as it defines it, because we need a context of assessment which is not one and the same in the context of use for us to be able to tell that they're both disagreeing on the same thing, on P, and they can both be accurate vis-a-vis P. But obviously to do that we need a third point of view that somehow allows us to arbitrate that. And obviously my worry is, okay, this is all good when it comes to taste and funny and so forth, but how does that translate into the language of science, and what will count as the third element? Okay, it cannot be any of the parties involved in the dispute, it cannot be some ideal assessor that decides matters of scientific controversies. And so it seems to me that that's a space of metaphysics, that's the role of metaphysical ideas. We need to have that scoreboard, because if we don't even share the scoreboard, there is really no way of sharing knowledge and have a meaningful dispute and controversy on whether or not there is dark matter, whether or not the monoxide is a kind of water, and so forth. So that's the regulative role that I see as a reason playing in that debate. Now on Kant, here there's a huge literature. I have actually papers on this that are unrelated to today's paper. There's a literature on Kant's transcendental illusion, and the debate there seems to have been on how to understand these really puzzling and striking passages of the transcendental, the appendix to the transcendental dialectic, where some people, mainly people like Allison or Michel Greer and others, have been interpreting Kant as saying that Richard Zuckert more recently, that we need some sort of placeholder for metaphysical objects. So when you talk about objective truth, I don't know what Kant would say about that, because he has a notion of truth. He believes that truth is agreement with the object, but obviously what he means by object is object of experience. It doesn't mean some nominal objects, because for Kant nominal objects are not objects of experience, something that we can come to know. So if we stick to his view of truth, then obviously I think Adrian Moore may come back, and maybe justified probably in coming back and saying, well, given what Kant says about truth as agreement with the object as object of experience, how would I ever know that my object of experience coincides with your object of experience, everyone else's object of experience? How do we know that we actually share knowledge, we're talking about the same thing, and that we're not just trapped into the solipsism of our minds and our epistemic faculty? And I think Kant had an answer, and that answer hasn't got to do with nominal objects, precisely because nominal objects are vanishing points, are things that are behind the mirror, they're not a real thing. But they play an important, what he says, indispensably necessary illusion, the illusion of making us think that there is an order of nature, and there is an order and systematicity in our cognition that we should try to achieve. And that's, anyway, that's how I read it. I don't know whether I answer your question, probably not. Don't seem persuaded.
Wave mine.
Paul?
Sorry, Michaela, I'm just going to ask a very elementary thing, because I'm not quite sure what you want to explain. I mean, if you take the dark matter controversy, so that somebody says that the explanation for this phenomenon is to postulate this, and somebody else says you don't need to postulate that. I mean, first of all, just at the level of truth, I think this is connects up with the third question. Presumably is a fact of the matter about whether there is or there isn't something out there. That you disagree with that?
I was dreading that kind of question. I knew it was coming my way.
I mean, I just want to know at what level perspectivalism is.
No, okay. Okay, let me get clear. Okay. I do agree with that question. I'm a realist about science, so I'll answer your question.
That's about the world.
Okay. Yes. So I've answered that question. But this is a paper on perspectival knowledge,
Okay,
and
let's
so
just do
on the metaphysical ideas of natural kinds.
We'll get there through a kind of catechism. But you think there are facts out there,
Yes.
and they are what they are, irrespective of what scientists think or don't think.
Facts on natural kinds. Facts, properties, natural kinds,
Distribution of
patterns.
patterns over space-time.
Well, those are an important distinction.
No,
I mean,
fair
those are where the
enough.
metaphysical distinctions comes in.
Oh,
Because the point I was making today
yeah.
is that I agree with Kant's view that
I see,
ideas
I
of
just-
natural okay, forget about Kant, okay?
Yeah,
Because
so
some people come out in a rush.
Keep it as simple as
Forget about
possible.
it.
I mean, if there is a fact that there is, now you see the thing, McFarlane is a truth relativist.
I'm not.
The framework doesn't.
Actually, there's a danger that
Could I
with
make one correction? Please.
very quickly, and then we have to stop.
Okay, but your dark matter hypothesis is not correct. It's not empirical in nature. The point about dark matter is, as Vicky pointed out, if you can see something, it doesn't, if something has matter, it doesn't follow that it can be seen. So it's not just an empirical thing. And it always makes me philosophers don't get that. What he's saying is it's an unexamined assumption. Everybody realized immediately we had assumed that all matter can be seen. Vicky's point was, we can't assume that. There's no reason. We don't know of any connection between the gravitational interaction and the electromagnetic interaction. And therefore, and I know physicists often misphrase it, but that it is actually a philosophical in nature. It's not an empirical thing. Yes, it explains all sorts of things very nicely, but the thinking behind dark matter is not, it fits in very nicely in this model. It's, we cannot assume that something that gravitates can be seen. We cannot make that assumption.
Sorry, I'll
I'm
not
afraid
take
we're
you
going to
for
have
what I said.
carry this on in the
Because
way.
I explained
Coffee break.
briefly
Yes,
how
we
the
have
idea
soft
of the
coffee.
hypothesis was introduced to explain the galaxy clusters.
Yeah, that's how it was introduced.
It was introduced.
Yeah.
That's what I introduced.
Yeah.
Then until the 1960s, the idea didn't pick up. And then people, physicists had this trouble explaining the stability of galaxy rotation curves. So the idea resurfaced in the 1960s. And then, obviously, when the problem of galaxy rotation curves came out, then the idea of a spheroidal halo of dark matter seemed to fit very nicely with the lambda CDM model.
That's not the only reason behind it. That's
No. That's why I said there's a cosmic microwave background that can be explained unless you assume that. But I haven't made any claim about whether I'm, I didn't make any metaphysical claim about that matter. I was using that as an example to illustrate how people may disagree on whether or not it should be introduced in that specific context of the mental scale to explain the evidence. No. Okay.
We
Okay.
go to Shine can speak again and then go coffee.
Thank you.